Welcome back, students. Uh, this is the session number 5 from the chapter of laws of motion, and today we will be discussing about the law of conservation of momentum. Now, I have written a definition of this law of conservation of momentum. It states that in an isolated system, what is an isolated system? An isolated system is a system which has no external force, or we can say it is a system with no external force. So in an isolated system, mutual forces between pair of objects can cause change in momentum in the individual objects, but the total momentum will remain unchanged. Now, this fact is known as the law of conservation of momentum, and we will try to understand it with the help of an example. Now, in this example, I will be using the Newton's second law and the Newton's third law of motion in order to derive the law of conservation of momentum. So let us consider an isolated system. Consider an isolated system. An isolated system consisting of two bodies, say A and B. So I have considered an isolated system consisting of two bodies, say A and B. And what is an isolated system? An isolated system is a system with no external force. Now, let the initial momentum of A and B be PA and PB respectively. Okay? So I have considered the initial momentum of the body A as PA and the initial momentum of the body B as PB. Now, let these two bodies collide with each other. Okay? So first step is that I have considered an isolated system which consists of two bodies, say A and B. The initial momentum of the body A is PA and the initial momentum of the body PB, the body B is PB. इसके बाद में I have considered that there is a collision between these two bodies. That is, these two bodies A and B have collided with each other. Now, let their momentum after collision be PA dash and PB dash respectively. That is, after the collision, the momentum of the body A is now PA dash and the momentum of the body B is PB dash. ठीक है? Initial momentum A का है PA and initial momentum जो body B का है वो PB. After the collision, the momentum of this body A changes to PA dash and the momentum of the body B changes to PB dash. So अब if the initial momentum was of the body A was PA and the momentum after the collision was PA dash, then the change in momentum क्या हो जाएगा? The change in momentum of the body A after the collision is equal to PA dash minus PA. ठीक है, ये हो गया. This is the change in the momentum of the body A after the collision. Similarly, the change in the momentum of body B change in the momentum of the body B will be equal to PB dash minus PB. ठीक है. Now I will be using the Newton's second law of motion here. So as per the second law of as per the Newton's second law of motion, the rate of change of momentum is directly proportional to the applied force, and in the SI system of unit, the change in momentum, that is delta P upon delta T, is equal to F, because the constant of this proportionality, that is K, it has a value of 1 in the SI system of units. So delta P upon delta T is equal to F. It implies that delta P is equal to applied force into the time of impact. So using the Newton's second law of motion, we can write that the change in momentum of A, that is, it implies that PA dash minus PA, this is the change in momentum, will be equal to FAB dot delta T, where delta T is the time of impact. And हम इसको और भी ऐसे लिख सकते हैं कि PB dash minus PB will be equal to FBA dot delta T, where FAB is the force exerted on the body A by the body B, and FB is the force exerted on the body B by A. ठीक है. So I have got these two equations. That is, I can just give this equation as, mark this equation as number 1, and this is the equation number 2. And I got these two equations by using the Newton's second law of motion. ठीक है. Now ठीक है. Now here FAB क्या है? FAB is the force exerted on A by the body B, and FBA is the force exerted on the body B by the body A. So ये दो equations हो गई. Now Now what I will do is I will use the Newton's third law of motion. The Newton's third law of motion says that every action has an equal and opposite reaction. Okay? So, in other words, we can say that using the Newton's third law of motion, that is, every action has an equal and opposite reaction. Now here action and reaction are nothing but they are simply the forces. So using the Newton's third law of motion, we get this FAB will be equal to minus FBA. ठीक है ना? This FAB is the force exerted on A by the body B, and this FBA is the force exerted on the body B by A. ठीक है? Now these two forces are equal in magnitude, but since they are acting in the opposite direction, therefore I have these. Therefore, this FAB will be equal to minus FBA. ठीक है? So what I will now do is, let us mark this equation as 3. So what I will now do is that I will be using this this equation number 1, equation number 2 and equation number 3 to derive the law of conservation of momentum. So अब हम क्या करेंगे, यहाँ पर FAB है और जैसे ये आपका है FBA. So what I will do is I will just substitute the value of FBA from this equation number 3 in equation number 2. So it implies that first equation मेरी क्या है, PA dash minus PA is equal to FAB into delta T, and in the second equation what I will do is I will substitute this FBA by minus, say FAB is equal to minus FBA. So FBA will be equal to minus FAB. So I will get as PB dash minus PB is equal to, this will be equal to FAB माइनस यहाँ पे हो जाएगा, ये आपका माइनस हो जाएगा इनटू डेल्टा टी. ठीक है? Now I will be using these two equations now in order to derive the law of conservation of momentum. So what we can do now is we can simply I can do one thing, that I can just mark these equations. I can simply just divide both these equations on the left hand side and on the right hand side. ठीक है? So that is PA dash minus PA divided by PB dash minus PB. This will be equal to FAB dot delta T divided by minus FAB dot delta T. What I have done is that I have divided both these equations, that these two equations, on the left hand side and the right hand side of the equation. So by dividing these two equations, we have got this this equation. So it implies that यहाँ पर क्या है, आपका ये cancel हो जाएगा, and finally यहाँ पर आपको बचेगा which is equal to -1. ठीक है? ये माइनस साइन है यहाँ पर, so it will be equal to -1. So what we can write is now that PA dash minus PA will be equal to, ये आपका -1 यहाँ पे आ गया, so it will be equal to this माइनस एंड माइनस हो जाएगा आपका, दैट इज इक्वल टू PV, और ये हो जाएगा माइनस PV डैश. ठीक है, -1 इंटू ये जब से मल्टीप्लाई करेंगे सो आई विल गेट एज दिस माइनस PV डैश हो जाएगा, एंड माइनस माइनस ये प्लस हो जाएगा, सो फाइनली आई विल बी गेटिंग PV माइनस PV डैश. ठीक है, सो दिस इज फाइनली इक्वल टू PA डैश प्लस PV dash is equal to PA dash plus PB. Sorry, that is, so finally from this equation we are getting PA dash plus PB dash is equal to PA plus PB. Now, this PA dash plus PB dash is the momentum of these two objects, that is A and B, after the collision, and this is the momentum of the body A and B before the collision. ठीक है ना? So in other words we can say that the initial momentum is equal to the final momentum. Initial momentum before the collision is equal to the final momentum after the collision in an isolated system. ठीक है ना? यहाँ पे ये देखिए PA dash plus PB dash is the this is the final momentum, ठीक है, after the collision, and PA plus PB is the initial momentum of the body A and B before the collision. So the initial momentum, so from this equation, let us say I am just from this equation, that is ये जो यहाँ पे equation है, this one, yeah, so from this equation we are getting that the initial momentum is equal to the final momentum, and this is true in the case of an isolated system. So in this way, by using the Newton's second law and the third law of motion, we have derived the law of conservation of momentum. That is, the initial momentum of a system of objects in an isolated system will be equal to the final momentum, ठीक है, and this equation, or you can say this law of conservation of momentum, is true for both the elastic and the inelastic collision. So we will be studying about this elastic and the inelastic collision in the next chapter, that is in the chapter of work, power and energy. ठीक है, so this is what I just wanted to discuss in this session number 5, that is the law of conservation of momentum, and I just wanted to discuss this law of conservation of momentum with the help of an example. और यहाँ पर मैंने एक एग्जाम्पल लिया था जहाँ पे कि हमने I have taken an isolated system which had two bodies A and B. So the initial momentum was PA and PB, and after the collision their momentum was PA dash and PB dash. So with the help of the Newton's second law and the third law of motion, we have found that the initial momentum before the collision is equal to the final momentum after the collision in an isolated system. So this is the law of conservation of momentum, and so in this session we have in this system what I just wanted to discuss was how this law of conservation of momentum was derived and how we have achieved this equation. So this is all I have for the session number 5. In the next session, that is in the session number 6, we will be discussing about the equilibrium of a particle, and thereafter we will be solving few numerical problems in the subsequent lectures. So thank you very much for joining this session, and I hope you have understood what was taught today. And this session number 6 will be uploaded very soon, maybe in a couple of days from now. So thank you very much for joining this session, and have a nice day.